try and go with. So we've been around since '87, basically in that time listening to what racers want from us as a company to win. And so we've got a lot of practice and hopefully a lot of features that helps people do that. Yep. Yeah, 200 dealers around the world, and it's all, despite a lot of people thoughts, it's all based in Australia. We don't manufacture from our office, like it's robotically assembled, etc. And we test and send out the product from Melbourne. And we've got a large infrastructure, obviously, helping us. And for you guys, we hopefully have a kit that's easy to bolt on and turn the key and go. It's the same thing that's used in the majority of those pictures you just saw, just you guys have got the 4-cylinder version of that. So as far as the Yamaha is concerned, it consists of that M400 marine ECU. It's fully potted now, and so it's basically filled up with polyurethane to stop the water getting in. Got that installation set that includes the brackets and bolts and everything you should need bolted on. Simple tools and you should be on your way. PVR's got his hand up. It's been up for ages. If you want to get your hand back down, you can re-click it, I think, and it comes back down. Okay. So the ECU itself, we could call it relatively dumb when we send it out to our dealers. It's got a start map that probably realistically wouldn't start anything. The dealer, the person that you're dealing with, and you buy your ECU from, should load the map that's going to best suit your engine. And not only the engine, it's your type of riding, whether you're offshore and riding off big waves, or close course, or riding up smooth rivers. I'd have 3 different settings of rev limits alone for those 3 different styles of riding. I'd have potentially 3 different log sets, and also 3 different fuel tunes, and maybe even 3 different ignition. So to maximize to maximize the engine and the performance of your ski, kind of to do the best job, need to have a map to suit what you're doing. And if you do a lot of different things, well, you should change your setup. But what we're talking about here is the finer detail, and we're encouraging people to tune what they've got to win. That's our philosophy. So the whole saga of grabbing a map from someone and loading it and thinking that's going to be the greatest thing, it just doesn't work. And the sharing of maps is great, but because each one ends up being so individually set up for a particular Lambda sensor, for a particular maybe dual RPM limit, or all sorts of things, just loading someone else's map isn't always going to get you the best result. So obviously you've got to start somewhere, and we do have those start maps on the web, but you're by far better to take one map and then work on it, develop it, and stick with it. So all those individual setup things like the Lambda sensor and your log set and all that stay there. You can copy in fuel maps and ignition maps, and that's not a bad idea, but even then, lots of compensations that go on in the background that we might change, or that a customer or your mate might have changed to suit his application that's not going to suit yours. So it's just not that straightforward. Now, yes, we can produce a map that's nice and safe and kind of does everybody, but that's like a stock ECU, and trying to get rid of those after all, make something that's going to be good for your exact situation. So definitely need to put as much time in telling us about what you've got and what you want to do. In particular, the people that have been dealing with me, and you'll see it on Green Hulk, we want to know what fuel you run. The reason for that is the more ignition timing you get into an engine, to a certain degree, the more power it'll make. The offset to that is if you put too much timing in for a certain fuel quality, bang, the engine's dead. And there's a few people on here already that know what it costs to fix a broken engine. So we don't want to be handing out maps or advice without knowing the quality of the fuel. If you've got really good 109 race fuel in there, almost try just about any ignition timing for experimenting how much the speed you'll get for a given timing. If you're running the 87 octane, you've got to be very careful about what timing you put in. All right, so information is everything for us, and as I've said, you can do better with fine tuning. If you want to learn more, obviously this is a good method. The PWC manual's on our website. Go onto there, which you've all gone onto to log into here, and under downloads and under downloads and manuals, you'll see a whole lot of different manuals for all our different products. That's got a lot of information. Some of the information you'll get today is from there as well. Definitely need to worry about our cooling on our Yamahas. Most, I'm sure, will know about this. It's quite common now. You can't even stick your little finger in the hole of the water supply to the entire engine and intercooler on a standard setup. So that's no good for anything with any 200 odd horsepower that they've got standard. And you guys, once you're in there, changing all that hosing, if you want to go racing, you've got to be very careful about that hosing and the connections and the hose clamps and the pressures that are involved. You can get too much pressure going to, say, the intercooler, and it'll either damage the intercooler or split the hose, that type of thing. So I don't like people running around with our gold boxes on them stopped on the side of the river because of a mechanical issue. So I encourage you to really concentrate on that. So that's the installation kit that we do for the Yamaha. Again, most of you are familiar with that. Mobilizer up the front, or up behind the panel on the front storage. It's probably the most difficult thing. It's not that bad. Mount the ECU so that it's hanging down, and again, I really encourage you guys to make sure you put that plastic cover back on that covers the ECU and the wiring there. Now, make every effort to make sure the looms are as waterproof as possible, and in fact all the other lot of connections. You can help that by keeping the water off it to start with, and that's not a waterproof container that the ECU is in, but if you have that cover on, it certainly stops 99% of the splash. If you sink the boat, then you need to get all that stuff out, get the ECU out, get the wiring loom out, and contact your dealer about the best thing to do. You certainly need to get it dried out. It's more the connectors and the pins and the those splices and things like that that get the water coming weeping in through the loom, that you've just got to dry everything out. You won't have a problem on the day you sink it. It's a month later that it's going to give you the problem. Okay. Well, we got some accessories that you can add to this thing. You've got when you purchase one of our ECUs, it's extremely powerful. It's like a glorified multimeter if we think about it simply. It can measure just about any sensor you want to connect to it, and it can, like a network connection, talk to other products. So it can talk to our dash, it can talk to our Lambda meters, so you can add extra sensors. Now anyone doing a turbo should have an exhaust temp on it, and fuel pressure is a must for anyone who's serious in racing. You know that fuel pressure, the pumps and regulators are a very common failing item on a racing vehicle. So you need to know that your fuel pressure is going down if you have a problem. You can have Lambda on there, and that's certainly a good thing to do. But if the Lambda is going lean, you don't want to be adding fuel to your fuel map if your fuel pressure is going down. So fuel pressure and oil pressure and things like that, just standard stuff, you should try and get them into your logger, into your M800 or 400 for you. Okay. Just going to go through some ECU basics. Some of you this will be very simple. For others, learning curve. As I said before, the ECU is just like a relatively smart multimeter. It measures different sensors around the engine and effectively just measures voltages of those sensors and brings them into the processor. The processor looks up the calibrations that we've put in there and then decides what to do about turning on injectors for a certain amount of time and ignition at a certain time. So the standard things going in are the crank, trigger, throttle position, manifold pressure, that's your boost, engine temps and air temps, and extra things like your Lambda or AFR sensor, GPS and speed and exhaust temp, intercooler, anything else you want to learn. And then, not like a multimeter, it controls things. So the obvious ones are the fuel injectors and the ignition system, but it also controls other devices such as, for you guys, the drive-by-wire motor, maybe boost control, the idle speed, the fuel pump, not cam control, but anything else you want to connect to it. A nice simple example of what you could do is if you found a solenoid that opened up, let's say, some extra water, or opened up and allowed water to flow, you could very simply hook that to the ECU and program that extra water to come to your engine. Say the RPM went above 7,000. I think some of your engines now are getting a little much water through them, and they're running a little cool until you're going flat out. So it'd be kind of nice to just add the water when it's required. Some work to do there with thermostats and bits and pieces. It'd be nice to have those engines running so at least 60 or 70 Celsius. What's that? 50 Fahrenheit. Most of the time, and then without overheating when you open it up. So you can do that very easily. Sort of a solenoid, a relay, or anything like that, it's quite easy for it to operate and program when it. Okay, so inside the ECU there are tables, and effectively they're like pigeonholes that the computer looks up when the engine is operating at a particular, what we call site, or a particular area. So most of the tables that we'll talk about today are RPM across the horizontal axis and manifold pressure or load efficiency up the vertical axis. So when the engine's running at a particular point, the ECU looks up the tables relevant and applies the number that's in the table, the calculation, and whatever that table is associated with. And an example in front of you, that's the ignition table. And in the screen capture that we've got this on, the throttle position 0, and it looks like it's either trying to start or cranking, so it's doing just 500 revs. And what we're asking for in this table, as you can see, is 10 degrees of ignition. The thing to remember though is that this is just the beginning of the calculation. So this is the user input to what ignition timing we want, but there's also a lot of other tables that compensate this one. So if the engine's really hot and maybe overheating, we'll have another table that's based on engine temperature that pulls some timing out. So just because it says you're getting 10 degrees in this table, it doesn't mean that that's what will actually happen at the engine. So in order to tune, there's some relatively simple tables you can change, but you must remember that there's other things happening that could affect what's going on. So learn about all those tables and know, just try and familiarize yourself with what's happening. One of the key tables we use for fuel tuning is the Lambda table, and hopefully you guys are starting to become familiar with the term Lambda. The Lambda table is is what we call out, well, it's used for the perfect lambda or the perfect AFR that you want this engine to run at. So you manually fill out this table to look like or to represent the AFR that you want to run at each RPM and load. So again, in the example, customer in this case is holding the throttle at 20% and the engine hasn't started yet, so the lambda table is returning a value of 0.95. Everyone's going to ask, what the hell is 0.95 in AFR? I'm going to tell you how to work that out. Take your known AFR. If you know an AFR number, divide that into 14.7, which is the stoichiometric number for petrol. You will get the lambda reading. So if we have a number of 12.5, for instance, so you might say my air fuel ratio I should have is 12.5. If you go 12.5 divided by 14.7, you come up with lambda, your lambda number. All right, so the reason we use lambda is that calculation has to be different for every type of fuel, because the stoichiometric air fuel ratio for petrol is 14.7, but it's different for methanol, it's different for ethanol, it's different for LPG, it's different for diesel. So there's always a different air fuel ratio number that you've got to learn for each different fuel. Whereas for lambda, it's the same for all fuels. So it's one of the reasons that we stick with that, because we have customers using so many different fuels. So we use this table to tell the ECU what is our perfect air fuel ratio for any given load or RPM. So we start conservative when we're learning to tune. Rich isn't a bad thing. A rich mixture really doesn't lose a lot of power. It certainly loses some, but it's not as much as what you think. And I'd like to start, if you're learning to tune, start thinking rich numbers, and see some examples, and you get plenty of advice from your friends, but numbers of sort of down in 11.8 you hear bandied around a lot, and even numbers as low as 11 to 1, down to 0.75. Sounds awfully rich to the race guys, but the engine will run okay at that, and if you get everything else sorted and your ignition curve sorted, it's very easy to quietly take the fuel out of it as you get used to tuning. If you go jumping straight in and trying to run a race mean and lean air fuel ratio from day one, well, you get that wrong and you got too much ignition timing in it. We end up with broken parts, and don't need to start your learning experience with that. And yes, I see Dean has said 0.86 is an ideal level. Lambda is actually all about how you're using it. Rattle on for 5 minutes about that. If you take, let's grab a typical Yamaha at 1 bar of boost, which is 14 pound, which is 200 kPa on the, how you read it as a absolute pressure. So that's your E1 standard wheel at about 8,300. And if we're going racing on our bridge-to-bridge race, like they did in Australia here recently, I want to tune that. That's 3/4 of an hour flat out, going really fast. So, but let's say 40 minutes, wide open throttle. I'm going to want a lambda reading of at least 0.80, and I'm not going to be disappointed if the tune ends up at 0.78. So down around 11 to 1, 11.8, something like that. And the main reason for that is to decrease the exhaust temperatures, because you're going to be flat out on this thing the whole time. So temperatures are going to rise, the valve temp's going to go up, the piston temp's going to go up, everything gets hot. So yeah, we'll lose 5 or 6 horsepower because we're running rich, but that really doesn't matter, because it's all about finishing the race. So spend some more time on your ride plate and things like that, rather than worry about tuning it lean. But if I'm going to the World Finals and it's a 2-lap or 3-lap dash, and I want to win, and it's the last race of the last moto of the session, then I'm going to be leaning this thing up, out to sort of maybe 0.89, even not much more than 0.89. Now that's lean, especially for a bar of boost. Reality is that on a closed course race where they're up and down off the throttle a lot, the engine is not spending a lot of time at those air fuel ratios. Coming up and down off on the throttle, it's getting a squirt of acceleration enrichment. So really, it's only at that load for maybe 20% of the race. So that means I can get away with a leaner mixture. Ideally, around that 0.88 is maximum power, but you need to make sure everything is strong, and you are risking damage at that point if there's anything weakening. So, like Dean said, 0.86 is it's actually a good number, but you need to make sure you got everything sorted. Everything sorted. And long endurance stuff, get it rich. Come back on it. Right. So, let's talk about how to hook up. It's nice and simple. We want to open our ECU manager. The crossed finish flags in yellow that you'll see as an icon on your desktop. ECU Manager and i2, which is the data analysis program, they're both on our website and of course free to download. You need to have them on your laptop before you get going. You're also going to need that thing you can see on your screen there, the UTC. And it stands for USB to CAN. So that device has a USB cable plugged in and just goes into your USB slot on your computer. Make sure you've got the software installed on your laptop before you plug that UTC in, because it's got the drivers in it. Now we need to power up the ECU. Now on a race car that's normally very simple. We just turn on the ignition key or the isolator switch. On these PWCs things, they drive us nuts. Poor old Dwayne had to work out how to get these ECUs to power up. And when it came to the Yamahas, because the ECUs on these things, certainly on the Yamahas, there's no power at the ECU. Which doesn't make sense really. There's no power there for us to use. So what happens on the Yamaha is the factory relay, etc., detects the starter being pushed, and that wakes the whole thing up. Now, the way we've got it set up for the Yamahas now is if you push the starter, bump the starter for like about a second, that will wake up the ECU, and a little timer will keep the ECU, our M400, alive for about a minute. So if you need to do something quickly, that's all you need to do. But if you want to keep the thing online without the engine going, for an extended period of time, we've provided a wire for you to ground. So that wire is labelled, and you'll see it on the loom, power up I think, and all you need to do is chuck that onto an earth. Now my friend Ed has put a nice little switch for that in, and flicks the switch and the thing powers up. So you can get your logging, you can send maps, and you can go online and make changes, and the ECU will stay powered up, so you can do that. Once you're successfully online and you open ECU Manager, you should hopefully see something that looks like this. Now, anyone who's got a lower screen resolution is not going to see the finer detail of the screen, I'm sorry. The sample PC here, and it certainly looks average. I'm going to work on this stuff. Hopefully what you will see is that we've got a green icon down the bottom. Now what that means is you've successfully connected to the ECU, and the two, your laptop and the ECU, are talking to one another. That's good news, let me tell you. Because we've been going for a long time, we've got many levels of software, and you need to have the matching software on your laptop as what's in the computer. Otherwise the two won't recognize it. The other thing you can see when you hook up on that first screen on the left hand side, you can see the list of options that your ECU has got. grab this green row here. That's basically these here. And as I say, some of you probably can't see those. I'm sorry. You'll also see down here in that bottom corner, again, might not be able to read it now, that'll give you the version of firmware. Now, sometimes we might be asking you that. When you have a problem, we'll ask you what software you've got, and that's where you look at that. Apart from that, you can just go File Open. A number of different ways of getting online or into the program, but up the top here you can just go like Windows Stuff, File Open ECU. There's an icon for it, and if you're going to be using the software a lot, you can use basically only 2 or 3 keys to maneuver around the whole software, and they are Escape, Enter, and up and down arrow, and you'll find that you'll get a lot of places through the menu by using those keys. I'm told Mark, who's online somewhere here, is going to help answer questions as well. So if you see your guy Mark McCoy turning up, he's one of our tech guys here and can answer any questions. So feel free to type on. My man 5001 Craig is popping in and out. It's got no audio. It's a shame. It's going to be to do laptop setup, unfortunately. Along. Alright, so when you go to open a file or online, you will be presented with some screens like this. And so if you haven't ever been into this ECU before, you won't have a matching file on your laptop. So it's going to ask you if you'd like to start with a new file, if you'd like to use the matching file, it'll give you some options. I'd always suggest you start with a new file and give it some meaningful names. Or any meaningful names, you know, like FZR, stock class tune, FZR, whatever, bridge to bridge test. Give it the name. It'll always have the date, the time and date next to it whenever you save it, so you don't need to worry about that. And you can also it's quite nice if especially if you're playing with setups, might be turbo, different exhaust housing or different prop in the jet unit or whatever, just give some little indication as to what it is this file suits. So when you're looking through in the future your hundreds of files, you can find the file that suits your setup. And when you get it open, you'll be presented with a screen that looks like something like this. And this setup's completely customizable. You can design this screen to look any way you like. Now, what you see in front of you there, again, is fuzzy. You can set up dial gauges, bar graphs, numeric numbers, numeric lists, all sorts of things, and you'll just have to go in and experiment with the software. So you can go in and read the help, and it tells you how to do this stuff. So once you get a set, basically you want every sensor that's on your engine to appear on this list. Color it and put mins and maxes and all sorts of things. So you want to set up your screen so that if anything bad happens to any of the sensors, you kind of see it, catch it with your eye. You can see all the numbers of all the relevant things happening. So you spend some time practicing that. One of the first screens that you'll use, apart from their main front screen, is called the view screen, and you can shortcut to that by pressing V. This is like a whole lot of diagnostic screens that are in the background and give you lots and lots of information about what's happening and how the ECU is making calculations and things like that. And if you're on the phone to your dealer, they might often ask you to look in here. Now, when you very first press V for view, you'll come up with the sensor screen. And every sensor that's configured on this setup will come highlighted in black. There you can see we've just slightly to the right there, we've got main sensors. So we can see our battery voltage, our lambda reading. We can see that the second lambda sensor isn't configured and it's grayed out. See our throttle position, and if this engine is off, we expect to see around 100 kPa, which is ambient. This is a good way of finding out if you've configured that new manifold pressure sensor that you're all racing to fit now. you haven't configured your sensor correctly, then it's not going to have a sensible reading here. And you'll see if this engine is, you've just turned it on and you're in nice sunny Brisbane, and its engine temp is 25 degrees and its air temp is similar. So that makes sense. And because the engine's not going, the manifold pressure is 100. That makes sense. So before you even start the engine, go looking for problems. Make sure that everything is reading right. The fuel has had a fuel pressure sensor on it, and someone's had the fuel pump on at some point because it's still got 212 kPa. It's about 30 pound. See the internal temp of the ECU. So if you look towards the top of that screen, you'll see there's a whole lot of tabs. So on each tab, you'll see the diagnostic errors, which will tell you a whole lot of information about what the ECU is or isn't happy about inside. A fuel screen, ignition screen, boost screen, all these screens have lots and lots of information about all the calculations and measurements making to give you information to help you work out what's going on. All right, as I say, that we're kind of skating over quickly over this stuff, and it's not all as simple as what it makes out, but you can't learn to be an expert a day, a night, or a year, or even 5 years, if you ask me. For 20 odd, and we literally learn something every day. So let's try and cover the basics. So the next subject we're going to go on to is data logging, and this really is the greatest thing I believe that we do. Data logging just gives you so much information and so much ability to improve your riding, the ski, and the engine. Without this, you really are flying blind. And globally, motorsport now uses data logging to make the improvements needed to get to the front. The big gains on everything are all gone. The big gains on jet units, the big gain on engine tuning. Everyone knows that you need to do things within certain parameters. The only way to move yourself forward in the pack is to measure accurately small changes that you make. Now the gains will be small, so you need to measure very accurately what's happening, whether the RPM has got higher, whether the speed has got higher. So accurate data logging is really the way to move forward and things, um, in a good way for yourself, like to get things faster, whatever you're doing, whether your goal is to be the most economical jet ski there, the fastest jet ski, the hardest accelerating jet ski. The way to work on making that better is to record changes you make and see whether they're good or bad. If you accurately record something and you only change one thing at a time, then you only ever go backwards once. So as long as test conditions are similar, you know, for one step back, you should end up going 10 steps forward. So we use data logging to do this. The data logging records the channels that you choose inside the ECU, and not only are they the sensors that might be wired to it, they are things that the ECU calculates. There's even things like acceleration rate of change that's calculated in the complicated stuff that we're not going to do today. So you set the ECU up to record these things, you go do some testing, and then you download it. Pull that information off the computer and you put it onto your laptop, and then you use our I2 analysis software to look at what happened. So what that means is that given a certain level of safety, you can ride your ski, come in, download the logging, and have a look and see how it was running, how rich it was, how lean it was. And so you can tune it. And you can tune it the way it's being used. And tuning on the engine dyno is the ultimate way of making some power and doing some research. But the fine tuning just has to be in the ski. The real world test that you do is what you need to tune to. Sit down and accurately look at that data and make changes, not when you're pressured on a dyno or trying to write along with a laptop on your ski or something silly like that. So in the ECU Manager, there are there's some screens that you can change to decide what to record. Now your M400s come with 0.5 meg of logging, and when you're online, you can see on the bottom there are two parameters. There's the number of logged items, and in this case it's 48. And you have a maximum of 64 to choose, that you can, not to choose from, but that you can choose. About 100 or 200 channels to choose from. So 48 is okay for this example. And then you, as you choose them and alter the frequency that they are logged at, so if I just show you up here, the number that you put in here, in case of RPM is 20, that is 20 times per second the ECU will sample the data. So if the channel that you are sampling changes very quickly, certainly like RPM, then you need to log it fast in order to measure those changes. If it changes slowly, like air temperature, then you only need to log it slowly. So the more things you log and the faster you log them, then your time comes down. Now this is logging time in seconds. I hate this part about it. I don't know why we do seconds and not do the calculation for minutes to make it easy, but obviously if we divide that by 60, we'll come up with a number of minutes. So 11.3 divided by 60 equals, as near as damn it, 20 minutes. So what that means is when you download the logging, you'll get the last 20 minutes of logging. Now this is important to remember. If you go testing and you've got to travel for 20 minutes to go out through the 5-knot zone to do your testing, and you go out and do some wide open throttle stuff and you come back 20 minutes through your 5-knot zone to the trailer, you're going to get 20 minutes of idle, and that's not much fun. So your options, you have two options. One, you get your mate's big boat and go out with your laptop out to the sea directly. Two, you could try and extend the time by logging less things and logging them slower. And actually a third option is there's an ability to put a logging switch on the dash, another option. But the third option, you can actually put a switch on the dash that just logs when the switch is on. And the fourth option is actually at the, put a screen capture of it, but in the setup, the first thing you can set up is when the logging automatically switches on. So we can actually tell the ECU to start logging at, say, when RPM is above 4,000, let's say 3,000. So if we say when the RPM is above 3,000, turn the logging on, and then don't turn the logging off unless it's been below 2,000 for 20 seconds. So in other words, basically once you're on plane with this thing, the logging is working. And then once you come off plane for more than 20 seconds, the logging will stop. And that's a nice way of getting the data that you want and fill up with stuff you don't. So testing, this is really important. Testing is, if we're looking at data and we test different every time, the data is it's nowhere near as useful to us. We can tune our air fuel ratio and things like that, but if we want to measuring speed and acceleration and stuff like that, it's just critical to try and do our testing in the same way each time. So before we get carried away, we want to make sure the thing's warmed up. We want to make sure that engine's above 60 degrees because that changes the power quite a bit. And for doing lambda tuning or air fuel ratio tuning, the nicest way to get some logging for this is to actually hold on each particular RPM level that's in your fuel map. So our fuel map might go up at 2,000, then 2,500, then 3,000, then 3,500. There'll be table number intersections that we call sites at each of those 500 RPM increments. So those increments, or that site, so let's go with an example of 4,000 RPM and 100 kPa, but less. Let's call it 100 kPa, 4,000 RPM. We've got a fuel table number there that we can change. So when I go testing, I want to see some logging from 4,000 RPM and 100 kPa, and I'd like to see an honest second of logging. That allows me to read the Lambda sensor and have the Lambda sensor give me good information, not clouded by acceleration enrichment or other transient information. So when you go out, I want you to do what's called step logging. So go along and hold for 1 or 2 seconds at each RPM. Then when you download the logging, you're easily able to pick those Lambda values, those AFR values, and do tune offline. Right. So once we kind of get the fuel tune right and we want to do some acceleration testing for maybe jet unit development or anything else, then I'll often get our test pilots to idle along until you get to what we call maximum idle speed, because if you turn a corner and you're idling, the speed goes way down. So you actually want to be idling along, and it's probably do about 4 mile an hour idling. And then once you've got that point, then nail it to the, like squeeze that throttle hard and don't be a pussy about it. Like nail it flat to the boards the same way every time. And if you've got cavitation, then we're going to talk about how to fix that. But after you fix your cavitation, then that way, if you do the same test time after time after time, you will see gains in your speed trace. Obviously, speeds need a GPS speed, but anyone doing any development should seriously have a GPS on board. Wayne will remind me to talk about GPSs later. We won't cloud that issue yet. Here comes Josh. Oops. We need to fix that cavitation, as I said, and try and stick to the procedure. Right, we've gone out and we've done some testing, and we need to get this data out. So to do that, we hook up, go online, and in ECU Manager, go up the top, and I think it's under Utilities, Get Log Data, but you guys are going to be doing this a lot, so Control F8 is the shortcut, and seriously, that is what you want to remember. Out of all the shortcuts that we have, that's one of the more. So Control F8 once you're online, and that green icon is down the bottom, and the data will start streaming out. It won't take too long. After it's come out, you'll get the choice of whether you want to clear it or not, and maybe for the first few times you might want to leave it in there just to be sure that you've got your unload procedure correct. Certainly after you're used to it, I'd clear the data, and then you want to put in some comments like what you see in front of you here. So really want to put as much information here as possible so that when you come back and look at this logging in 2 or 3 years even, or months or whenever, we know what the test was about. So this one here, we've got a test for the opposition. First test, C3 wheel, RXPX. Doesn't make sense. Oh, RXPX intercooler. Yep, with 725 IDs and the fuel pressure down. So I know what the condition was from this test. Before we get into the analysis of that data, I really want to make a point about using a Motec. The number of people that are buying an aftermarket ECU, whether it's ours or Vipex or Phonics or anyone else's, once you buy an adjustable ECU, stop adjusting it with fuel pressure, injectors, and things like that, which is an earlier method of tuning a ski when you had a preset ECU. So you need to get injectors that are more than big enough to do the job, and then forget about injectors. You need to get the fuel pressure, seek advice about where you should run it, but after it's set and it's enough, don't touch it again. Like just leave it set. If it's 60 pound, that does just about everything. So don't put bigger injectors in to make it richer. Don't wind the fuel pressure up to make it richer. You've got a laptop. It takes about a second. You can add and subtract fuel anywhere you like at any point on the tune. Just on that, I get a lot of people asking me, oh, I want two maps. I want an economy map and a performance map. Well, when you tune a computer, have both maps all in one. When you're at 5,000 revs or 6,000 revs at half throttle, you can tune that to be economical. Then when you're full throttle and you need the power, well, you can tune for richer for that power. So kind of whatever you want, you can just about do in one map to a certain degree. Certainly, an economy map and a full power map are not required as two separate deals. They can be all done in one thing. All right. We'll get a question here. Still use rising rate part of the fuel reg or leave it off for a constant fuel pressure. All right. Okay. Here's what I found with Yamahas. Rising rising rate on a turbocharged or supercharged engine is it's a good concept on a racing car or on anything where you have control over the fuel pump and the wiring. The fact that the fuel pressure goes up with a boost is a good thing, and it means that the pressure differential across the injector remains similar. So it affects the shape of your fuel map, but that doesn't matter. But what it means is you won't run out of injector so easily, and it means that your atomization is better because you're kind of squirting with a higher fuel pressure into the manifold when the manifold pressure is up. So effectively you maintain the same pressure drop across the injector. What we've found, and I don't know that this is necessarily gospel, but we found that Yamaha fuel pumps, when the pressure comes up, and that's not necessarily Yamaha, but if you grab a standard fuel pump and you lift the pressure too much, you'll put it under strain and it'll draw more current. And what happens when it draws more current is it strains the wiring more. So things like the fuses, the connections, and everything come under strain. So the lesser evil out of like choice number one, getting slightly better atomization to increasing fuel pressure, or option two, the fuel pressure dying away at high, the fuel pump struggling and the wiring struggling and everything being unreliable at higher fuel pressures. It's not a good option. So I've been aiming at keeping fuel pressure down just for the reliability aspect. If you're building a race ski, you put in a race pump and you're putting in good wiring, then I'd run rising rate fuel pressure and custom tune to suit. If you're a stockish ski and you're just recreational stock class racing, nothing too carried away, well, you only need to run 50 pound or 60 pound. So both work fine. We're concentrating now on supplying more and more maps with a set fuel pressure. Like whether it's 51 or 58, it doesn't actually affect the overall fueling that much. I think the golden rule is something like double the fuel pressure, you only get about 1.3 times more fuel. 1.4 times, something like that. So that's doubling it. So increasing it by 10 psi doesn't affect the fueling that much, certainly a little bit. But my main concern with encouraging people to keep the pressures down is about keeping the pumps reliable and wiring reliable. So that's where we're coming from. All right, so tune with the laptops, log your improvements, develop your whole shop, and log it, log it, log it. It's all about the logging. Now, some of you are going to struggle with reading data. I wouldn't say it's easy. That said, out of all the systems that I'm aware of, it's one of the easiest on the planet. And once your laptop's set up, it really is very simple. And later on, if everyone's still awake, we'll try and get through to looking at some data. Now, at the very least, what you should do is learn how to send a log file. So get the log file out of your ski and send it to someone who can help you. Now, obviously, I'm available to help when I can, but what we'd actually prefer you to do is we'd originally like you to buy your ECUs from a Motec dealer and from someone who can help you. buy from someone who's got experience with jet skis and particular experience with Motec, send them the log file. They can have a look and help you with what's right or wrong, or help you make it go faster. So the way to send a log file, and we'll go into this in more detail shortly, is to basically open the log file in our I2 analysis program. And where you go to open it, if you right click on it, send it off to your mail recipient, or copy it onto a USB stick, or write it to a CD, or whatever you want to do. It's that point there that you can click on it and send it off to someone who can help you. Um, that that person could be me, and I can look at that log file and either call you, help you through what may be wrong, or I can look at the log data and give you some advice on what to change to make it faster, slower, leaner, richer, whatever. And if I have your file, I can change your file and send it back to you. All right, so get it off your laptop and send it off to someone who can help. If that person is sending you a new tune-up or a new config, that file will be at the current level of software, XYZ Yamaha FZR new tune-up.v35 or version 3.5, and you need to drop that into the directory that you can see on your screen there. So C drive Motec M800 V35. Once you paste that new tune-up file into that directory, when you go to online to the ECU, you can choose to send a new file, and that new tune-up will be there. Lots of love going on in the chat box, isn't there? All right. So, what I do, we'll have a 2-minute break. If someone needs to head off to do something quickly in the relief stakes or whatever, we'll resume in 2 minutes, and we'll start talking about data. Okay, so a 2-minute break, and we'll see you right back. Okay. Okay, I'm back. Up again now. I think I got a couple of people. It's a bit frustrating that either can't hear or can't see. And got my email address. might even Dwayne, when he gets back, is put up his email address, and we'll try and work through this stuff so that you can get on in the future. We'll post this up on our internet site after we've done some editing and stuff, and shortened it up a bit, and so that you can certainly listen to it and view it again at a later date. All right, so moving on to data analysis. It's a fairly large subject, and again, all sorts of levels of expertise with this, and the software program that owes us literally millions of dollars and more than 5 man-years to create. Actually used all the way up to like Indy cars, and basically all the way up to, but not including, Formula One. Extremely powerful, but don't be frightened that it's going to be overly complicated, because it's a lot of effort into making it simple to use. Once the basic screens are set up, it remembers everything that you leave set up in it. So once you get all of your Yamaha channels and so forth set up on there, it's relatively self-explanatory each time you load a log file. So there's 2 levels of the software, and unless you have a Pro Analysis upgrade, which is not the cheapest thing we sell, and really is only needed for high-end race guys, you'll use i2 Standard, and Pro Analysis on your device allows you to use i2 Pro. For the lion's share of you will be using i2 Standard. You open i2 Standard the first time, I want you to choose a circuit project. Really, the projects just identify the different ways in which laps are created. So a drag project is looking for your 60-foot time and your end time and things like that. A rally project sections you into stages. An engine project doesn't allow you to do anything like that. But a circuit project allows you to create laps. And eventually, we've got software coming that, with the use of the GPSs, that you're going to be able to do automatic laps in the M8 and the M400s. It's not quite there yet, but you can certainly manually install laps in the software, and once those laps are installed, it's very easy to overlay them, and it's actually an extremely powerful tool to use laps. You can very easily see differences from one test to another. To get started, click on project. Sorry, circuit project. Now, again, I'm just checking my second PC here with the poor resolution, and that's all a bit of blur. But this i2 software can be set up to look lots of different ways. Not only can it do squiggly lines, it can do XY scatter plots, which is that graph in the bottom right-hand page, right-hand corner of the page, and that, for those that can see it briefly, there is the plot of a unit pressure, I think it's that, or supercharger boost, and it shows you where that those particular channels have run in relation to one another. I'll go into that perhaps later. You can also set up reports. I don't expect you to be getting into this straight away, but it can give you minimums and maximums for your data very quickly, allow you to see if there's been any issues. By far the most commonly used one is the graphs page, so the squiggly lines, and you get a number of these to pre-configure, show you information about what you're interested in on that particular page. So we might set up a page for a tuning, and that would include obviously RPM and throttle position and manifold pressure and our Lambda sensor. But we might have another page to cover what I might call health. So that might be battery voltages, oil pressures, temperatures in general. And we go to each of these pages and have a quick look and make sure everything's in order. And, really reduces the time for deciding on, if everything's healthy and where it should be. That's probably most of it. Now, to open a file, obviously you've got to open the software to start with, and it's called i2 Standard, and then you'll be able to open a file by going up to the open folder thing, same as normal Windows, or go File, File Open. And you'll be presented with, by default, the logged data folder. Now you can separate all your data into different folders. You'll have to navigate over to each folder when you go, to choose different log files. By default, your ECU will throw the log data in the C Motec log data folder, and that's where you go look for it, unload, or when you go to view data. If you've got laps already created, or test laps already in there, you can actually choose a particular lap by clicking making the red dot go in that lap. So if I want to select lap 4, and this is a little bit backwards at the moment, but if we create some laps after some testing, you can grab one lap and then you can actually select a second one. So see here where we're pointing, the overlay lap might be lap 4, and we're putting that on top of lap 5, and that will overlay the data one on top of the other. Examples actually from one of our guys racing escorts here captured. There's two boxes that can pop out from either end of the page, and on the left is the channels, but on the right is the values box. Now, all the real keen data guys always have the values box open, but I don't actually usually do it. But it shows the value of every single sensor on that you've recorded or logged, and you can flick it in and out by just pushing V for values. You can open it by clicking open for it. But if you've only got a small laptop, it absorbs real estate, and I'll try and have all my logged channels set up somewhere on a graph somewhere in the program. So that values box, and it's nice to know it exists. You can change the layout of your setup. You can change what appears there, but by default on i2 standard we've actually got that locked, but it's just a matter of going down to layout and unlocking that layout, or unticking that box, and then you can configure your i2 page to look any way you want. What I'm going to do is just screen share my i2 program. Now as soon as we start screen sharing, everything slows down, so bear with me, but I know it's much easier to understand if you can see it. To work. We will be looking at this later. Let's get this to set up. There it is. All right. So it looks like you're missing a bit of chat. Let's get this lined up a bit better. All right. Again, for those with poor screen resolution, this isn't going to be good, and that's me moving my mouse around here. Go to the layout. Well, my layout's already unlocked, so you've already seen that happening. What it means is we can move around. See me dragging the screen up. I've done it. All right, there it is. And right click and add a scatter plot. And set up my scatter plot so I can go add y-axis. I'm going to run manifold pressure. So I'll look at the turbocharger efficiency, and again this is just going to be blur if you've got a really bad screen. What's it like for you, Dwayne? marginal. Yeah, I'll quickly go through this, and I need to set up all x-axis, so I just choose RPM. So basically this is RPM versus boost. Click OK, and I can set up a color channel that also represents different throttle positions, so each color is a different throttle position. Probably losing something about now. Can we hear any snoring? Quickly go through this. I need to do some zooming, so I'll have to do some rescale. Probably the hardest part about this stuff is getting this initial setup done, but once it's done, it's it remembers it. So all right, that's a relatively small amount of data, and so our XY scatter plot doesn't show us too much, but we can see as the RPM goes up, the boost is going up, and we can see the color as the rider uses different throttles, the color changes. I've got to say that's not real right at the sec. Anyway, you right click on the grey screen and you can set up your page any way you want. Most useful to start with though is just a graph page for everything. So I've dragged that graph page down. I'm going to be interested to get your feedback. I'd like to know from you guys after the fact. Oh, Hot Rod's gone to sleep. How reasonable these graphics were. I'm going to stop sharing that now. All right, so there's some information. It's a bit easier to see about that time distance graph. When we bring on a channel, the channel name. So our top channel I always make RPM. So we have the channel name and we have the value at the cursor. So wherever we click the cursor, that's the value of the RPM. Now by pressing M for min-max average, you get these values also, which are very useful. Later we'll show you a really good use for them. So for the what's on the page here now, the minimum value we see on the page is 1500. The maximum that we saw on the page is 8,826, and the average is 5,619. The average is not a lot of use at this point, but will be very useful shortly. So we can bring on different channels here and view the shape of the curve, what the lambda is, what the throttle was, what the boost was at any particular point, just by clicking and bringing the cursor to that point. Now, you can zoom in and out. Page, not yet. You can toggle between time and distance on the bottom, but we're not going to deal with that at this stage. And there's an active channel. By clicking on a channel, turn it into the active channel, and a whole lot of shortcut keys and a whole lot of things apply when you do that. Again, that's probably a little bit advanced for today. You can zoom in and out, and all the shortcuts are here, and you can study this stuff later. Probably the most common way to zoom in and out is to double click and drag. So if you double click quickly, lift your finger off the mouse, then pull across and then click one more time, you'll see that highlighted black part there will become full screen, and you can keep doing that till the whole screen is like less than half a second. You can also use the little rolling scroll thing on your mouse if you've got one of those, zoom in and out, and there's all these other shortcuts to do that. You want to see all the keyboard shortcuts. It's in the help file, and there's an enormous amount of help up the top there. Really keen on learning more. Obviously playing with the software is the best way, but the help topics will give you tons of information. So to set up a basic graph, we go into the properties of that graph. Now you'll get a graph when you first open your software, and it's probably got a whole lot of channel names on there that are no use to you, like corrected speed and G-force lateral and circuit car stuff. So once you're in the page, the shortcut is F5, and or you can right click and go to properties. Now in the properties here, there's a reasonably self-explanatory screen that allows you to add and subtract channels and move them up and down and put multiple channels on one panel and all sorts of things. It's just something you'll have to play with to learn how to do. And each channel, you can actually, once it's on the screen, you can right click it and change what you see. You can change the color of it, and in particular for you guys in the US, you can change things that may be appearing in kilometers per hour or in Celsius. You can change them to Fahrenheit, mile an hour, and that type of thing. Main use for that. You can also filter channels, put offsets on them, and all sorts of other things that we're going to get into today. The best way to find channels, especially after you've got something set up, is you push C for channels and a little flyout screen appears from the left, and this is the one I use all the time. And you just start typing the name of the channel that you want, and it automatically weeds out the channels that don't have that name, because you could have like 30 or 40 channels there. And if you want Lambda, you just start typing LA, and then the only channels that will appear for you to choose are the ones with L and A in them. So once you've got that there, you move your mouse down and double click on it, and it will automatically appear on the screen. You can view that data with a black background if you like, and there's in the options setup, options tools, I think, or something like that. You can change the setup to black background. Sometimes some people prefer that. It's not looking so flash on the screen, I have to say. This is an example of a pressures setup that we did for our Jetsprint boat. And if you have a look at the yellow trace, you'll see huge drops in oil pressure, and those drops don't line up with a drop in RPM. So you'd have to be concerned about that. And on the data itself, I think it was the largest drop there was at 5,000 RPM. You can see it's almost gone down to nothing. So we were looking for this problem, and this particular boat had G-force on it. We can see immediately as soon as we put G-force on it that it's only in particular corners that we are losing oil pressure. So we know that this is oil surge, and it's in this case, left-hand corners. So mechanic or sump man needs to do some work on putting some gates in the sump. You will actually have identical stuff on your Yamahas, and Yamahas, in fact all jet skis, suffer badly from oil surge. It's once you put an oil pressure sensor on, you'll see there's big dropouts when you're decelerating and stuff, because sumps are very small on them. Way to see it obviously and work out what's going on is using the data. Alright, now let's get back to the nitty gritty of tuning your jet ski. We want to tune for maximum RPM. Now, tuning on the water, I haven't got a dyno, so the only way I know, and I'm open to suggestions, but the only way to work out if you've made some more power is to measure the RPM. Now, once you get only to the point where you're only making small amounts of power, your RPM goes up relatively a minor amount, like 50 or 100 revs. Now, without having a method to accurately measure the RPM, you can't really tell if you've made like a 5 horsepower or 10 horsepower improvement. So you do a consistent test and you actually zoom in on a piece of full throttle and then look at the average of that RPM, you will see a relatively consistent number appear in the min-max average. Let's go back to that page. So if I show you, just in this example, even though it's not a good one, if I was to highlight from where the green arrow is there, perhaps from there to that point there, and just zoom in on this piece of data, that's a relatively consistent RPM. The rider hasn't taken his finger off the throttle, and even though the RPM is going up and down, if we average that, we'll come up with a reasonably accurate number of what it would be on a perfectly calm piece of water. So that number can be used as a measurement for how much power you just made or lost. So you can go out and do tests like very, very carefully lifting ignition timing and seeing if that actual gain gave you any horsepower. Um, changing your air fuel ratio, changing the ride plate. If you don't have GPS, if you picked up RPM, you can probably conclude that you're going faster. So by zooming in and using that average as a way of finding out if your average RPM has gone up, it'll give you an indication that you made a gain. I've got some really good data of that. If I get time, I'll show you later. All right, RPM limit tuning is a big subject and something that's quite critical to PWCs, and in PWCs is more critical than any other racing that we know. If you get the RPM limit tuning wrong, I could take two skis and go close course racing and have one ski, I kid you not, nearly 4 miles an hour faster than the other with identical boats, identical riders, identical tunes other than the RPM limit. And the reason for that is that when the engine hits the RPM limit, it obviously, to stop the RPM going up, starts turning off things. Now, in your Yamahas, you want to go through your tune files and select your RPM limit type to be number 5, which is ignition cut only. So ignition cut is what we want to run with, so that when the RPM drops, or when the boat drops back down into the water, the only thing we've got to turn back on again is the ignition. We turn the coils on and start dwelling and get the cylinder firing. We don't want to have to wait for the fuel to be right. So by having the ignition cut being the only thing that happens in RPM limiting, that limits one more thing to wait on when you come back down into the water. Now, if we assume that our engine can rev to 10,000 RPM, then the best way, or the fastest setup for close course racing in the rough, is to have the RPM limit out of sight, what I call the clean water RPM. So if your ski does 8,300 RPM across the lake on a dead calm condition, then that's the clean water RPM level. Now, if you go racing with that ski and you set your RPM limit to 8,400 revs, what happens is that as soon as it goes over, as soon as it comes out of the water, the moment it sucks a bit of air in the jet unit, it hits the RPM limit. The RPM limit correctly turns the coil off, or all the coils off, and then waits until you get below 8,400 before it starts turning them on. Now, when it turns the coils on, it's actually got to wait for the right time to turn the coil on. Then it's got to wait for the dwell period, which is the coil charge time. And only after all that's happened do you get your first spark. Now, we measured the deceleration rate of Chris Mack's boat when he was racing at the World Finals last year. Now, the RPM falls at a rate of 70,000 RPM per second. That's how fast it goes down when that G unit loads up with water. So it is falling like a stone. So it goes falling through that RPM limit that quick. And if your RPM limit tuning isn't as good as it can be, it might be 7,000 RPM before the first coil fires. So the strategy for close course racing is to have the RPM limit a long way away from the clean water RPM. So what that means is if you're going across a short chop, the RPM starts going up above starts rising. But if it doesn't hit the RPM limit and you land in the water again and it drops while the engine's still firing and you keep going. Now, of course, the only downside to this is that everyone will go out and raise their RPM limits to 10,000. What that means is that you'll get actual RPMs over revs on big waves of over 10,000 revs, and we all know what happens. A lot of people know what happens when that occurs. We have valves dropping and rods firing out the side and things like that. So the RPM limit itself is a compromise. If you've got a race engine with everything balanced on strong rods and it'll do 11,000 revs, then you can have your RPM limit high. You want your engine to last forever? We'll set the RPM limit at 8,000. You need to prop down for that, but it's not very fast. So it's a huge compromise, and you need to be talking to your engine builder and the people around you to make the decision of what's best. I know we went over that quickly, but you can listen to it later. All right, probably the most common thing that you guys will do, and especially when you're setting up your skis with different injectors and all the rest, is doing this fuel map tuning. So to tune the fuel map, we want to have a look at what the Lambda was reading, and we need to see engine RPM, throttle position, manifold pressure, and Lambda to do that. You'll notice on this capture here, haven't got manifold pressure. So this really suits a naturally aspirated throttle-based ski, an FX HO, I suppose. Anyway, we need the critical information sitting on our desktop, on our i2 logging screen, and we want to look at each position that the ski is running. Now, you'll recall I got you to do a step test log for your testing for logging Lambda, and basically you go to each RPM level and each manifold pressure level and record what the Lambda was. So on the example in front of you, if you can read it, we're at 6,000 revs, and in this case it's 100 kPa. Now on your ski that's probably going to be, 100% throttle, but on your ski it's going to be about 100 kPa at 6,000, and the Lambda reading in this case was 0.91. So we could write that down on a piece of paper if we weren't happy with that Lambda reading, and because later we're going to go into the ECU software and make changes. So we go through the logging and write down all the AFR readings that we're not happy with and that we're going to change. Now we come into our ECU manager and we come into the fuel table and we go to the site that we were just at. So we were at 6,000 RPM, and in the case of you guys, we could call that 100 kPa. So you bring the cursor with either your mouse or with the up and down arrow, sit the blue cursor adjust square at that site. So 100 kPa, if you look, here's 100, here's 6,000. So the intersection of those two and is this point here, and the ECU is using currently a number of 90. Now if you type the letter L for Lambda was, this will look up the Lambda table. So if you filled your Lambda table out, you might see, for this example, the Lambda table says we should be running 0.88. Now our example said 0.91, so we type that in 0.91, and if you push OK, the ECU will change the number in the fuel map, and next time you run there, it'll be correct. So what that means is you can tune offline. So you go through your fuel map and make changes wherever the Lambda or the air-fuel ratio wasn't correct. Now you can also do this online, and when we're training people to do this on a dyno and things, it's certainly the best way to do it, is to tune, to physically put the engine at 3,000 revs, put the engine at 4,000 revs, and make changes in the table live. Unless you've got an ultimate supply of laptops at your disposal, I'd recommend that tearing around with a laptop between your legs on the ski is perhaps not the best idea. Although we do have one customer who's built one into his dash. You can do some online live tuning, and you can do that not only just by typing numbers in to bring the Lambda right, you can do it with another shortcut that I'll show you next screen. On the ECU Manager program, usually you've got a Lambda table set up. Have a red line normally, that is the Lambda aim, so that's from the Lambda table that you fill out, and the green line in this case is the actual Lambda value. You can see those values here and anywhere else you want to put them. The fact of the matter is we can see, because the green line is above the red line, that this engine is lean, and I know my aim is to get the green line on top of the red line. Now I can do that by just bringing the number up in the fuel table, but there's another way of working with that. We can do what's called quick lambda. So if you push the Q key and you're on site, and what on site means is the blue adjust area needs to be where the engine is. So the engine in this case is 10% throttle, and that's going to be 1000 RPM odd. So you can get the blue adjust screen to the live site by pushing the space bar. And then once the blue adjust site is where the engine is, and on the site where the engine is, to fine tune this and get it perfect, you need to get that black dot in that target. That's what you want to do. You don't want to make any adjustments on anything unless the black dot is in that target. So once you get to that point, you can push the Q key, and what the Q key is, it does, it looks up the lambda table, looks up what the lambda is, and adjusts that number automatically live online for you. So you can go to each site and manually just push Q, and it manually changes the map for you. Now, if you do that badly, you end up with this type of scenario. And what I'm seeing is people sending me tune-ups where they've had a go at doing this, either offline or trying to do it. They must have done this offline. And the little asterisk or the little mark box, we'll call it an asterisk, the marker point there, the ECU automatically puts that marker if you have tuned that site when you're online, or if you can actually push backspace and mark a particular site. In other words, you can do a tune on it, make a change, and if you're offline, you push backspace. That means if you've got to rush away and do the dishes or whatever, hey, you can come back to the job and go, oh, I've tuned that site, don't redo it. What I can see from this particular file is someone has been pulling fuel out of this thing, and they haven't changed the surrounding sites. Now, a jet ski will run, this is the area a jet ski will run. It'll run up kind of this part of the fuel map. Just hold it and move it steadily through the throttle. It'll go through that part of the fuel map. Now, those sites aren't very accurate, even though the customer's probably done a good job of doing a lambda was type change to it. Because there's such a big number change from, let's say, this point here to this point here, what that means is when the engine runs up halfway in between, it's probably not going to be right. The shape of the fuel map should be smooth. So if you make changes and it looks like this, you need to lift all the rest of the map up so that neighboring sites are close together. And until you do that, you won't get consistent lambda readings. The shape of the map, I'm not saying it should look specifically like that shape, but nowhere on this map is there any more than kind of 1 or 2 numbers different. The shape of the map represents the airflow through the engine. It's the efficiency of the engine. So if the engine has reasonably smooth, if it's got a standard cam and it's a relatively stock engine, then the shape should be smooth. If it's not, something is wrong. All right, so if you make it richer at the top, obviously these numbers at the top will get higher. If you have it lean or you're closing throttle, you'll get the numbers falling away. So depending on the actual engine itself and the cam, that will depend on the shape. But one thing's for sure, it should be smooth. This is an example of this is a throttle-based map. So it's got a throttle position sensor as its vertical axis. And this is a map from a race car with a big camshaft in it. So that camshaft causes all sorts of inefficiencies throughout the rev range. But a big cam and correctly tuned exhaust headers and everything else net a larger gain up the top. So this engine here only runs up at these RPM. It's got a 6-speed gearbox, and down here where it doesn't run, we have lots of up and down inefficiencies. And if it's accurately tuned, you'll see the low spot. This is where the airflow is not as good and therefore the fuel isn't as much. Reflects down this kind of the same through all the RPM. So the RPM level, at any one RPM, the inefficiency you can see is to do with RPM, and that's camshafts coming in and out of efficiency. None of your maps should look like that. No, unless you've got a gigantic cam that idles like a busted you know what, you should have a smooth fuel map. So if it isn't smooth, it's something wrong. You should smooth it off and then recheck it again. Okay. So this is a typical manifold pressure based map. There's a fuel map out of it's actually out of an S15 race car, but the engine is standard. And this customer here runs it very lean at these lower RPMs. And as the RPMs coming up and the boosts coming up on it, it's got more fuel, but it's all smooth. Doesn't have big cams, standard engine basically. And as the engine gets past its peak torque rate, the fueling falls away. The ignition map out of that same vehicle, it's a very good ignition map where timing is removed at peak torque and then ramped back in. The general rule of thumb means down here where you've got low pressure and low throttle opening, you can have more timing, but as boost goes up, ignition timing needs to come back. The more you rev it, the more the timing comes up, but as you get to peak torque where your cylinder pressure is higher, the timing comes back. Ignition tuning, you can't do this accurately unless you're on a dyno. If you do this on the water, you risk damaging your engine. I know people are still going to do this because this is what makes for a winning engine. The general trend for ignition timing is when you're a long way wrong and you add 2 degrees, you get a lot of power. As you get closer and closer to the point where you get peak power for minimum ignition, you will make less and less power. If the fuel is good enough for the engine and you have race fuel and a reasonably standardish compression ratio, you'll be able to keep adding ignition timing. The ski will actually go slower and you won't do any damage. If you have like an SHO with 87 octane and you run over 30 degrees and you hold it flat, you're likely to damage your. It's very difficult to get the ignition map right, yet it's the most important part of tuning. We try and give you as much information about correct timing as we can, which is why we ask about the fuel you're using. If you run a map that's set for USA 94 octane and you put 87 octane in it and it's an aggressive, race-winning map, you're going to be likely to damage your engine. It's really damned if you do and damned if you don't. But the use of a professional or someone who knows what they're doing can net you some big gains, but I'm saying be very, very careful. We have knock systems and means of listening to engine for how we do it. We can do stuff on the dyno. Our recent jet ski testing, we'll actually listen to the engine while we're testing and we'll measure the knock on the logging, and we'll do 2 degree increment tests and measure the max RPM and see what we're getting. So if we can't get an engine on a dyno, we can find out what ignition timing makes most power by accurately measuring how many RPM it pulls. But you have to be just so careful. Okay, 40 minutes over, but full throttle timer. So what I'm going to talk about now quickly is launch control strategy for Yamahas. The overall strategy that we'll recommend you use is to use drive-by-wire throttle. Drive-by-wire throttle uses what's called a position translation table. So that's this table here I'm indicating. And up the top, this axis here is the driver request, or we call it TPD, throttle position driver. So if the throttle position driver is 30, as per my green arrow, this table here is saying make the throttle 30. If the throttle driver is 10, this table currently says make the throttle itself 10. Now this table can be any, I can have any axis here I want, and a simple table will only be single dimensional or two dimensional. So we would simply have whatever throttle we want for whatever driver request. Now we've been recently tuning a ski where the rider decided he just loved an aggressive throttle. So at 15% throttle request from the driver, we put in 40 here. At 20 we had 45, at 30 we had 50, at 40 we had 80, and at 50% throttle we had 100. So by the time the guy got to 50, the blade is full open, that thing's going like a dog shut up you know where. Alright, so you can change the relationship of the throttle blade compared to what the driver has actually got on the handlebar. Now for traction control, for launch control, use a full throttle timer to change what happens as you leave the start line. So on the vertical axis of this table, full throttle timer, and we've calibrated it up in seconds, so 0.2, 0.5, 0.7, you get the idea. Then we calibrate the full throttle timer to start at a particular throttle position. So under miscellaneous setup, it's a full throttle time throttle position. So the timer itself won't start until the customer has reached, throttle has reached 80%. At 80%, this timer starts and starts heading up this axis here, right? And over at 100% driver request, we'll have a look. So at zero full throttle time, I've got 100. And so that lets the boat accelerate. And as the full throttle timer starts incrementing up, at 0.2 of a second, I have the throttle position in this example going back to 70. At 0.5, it comes to 50, and it holds 50 until it gets to 1.25 and then phases the throttle back in. So what this means is that you get to back the throttle off, or the computer backs the throttle off when you leave on your race. Now the full throttle timer up the top here is a reset delay. You need to make that reset delay something like 9 seconds. What that means is if you back the throttle position off under 80 during the race, we don't want the full throttle timer to go off again and have that dipping of the throttle happen. So if we have a number of 9 in here, what that means is if the throttle goes under 80% for less than 9 seconds, nothing happens here. It stays way up here. You've got to be under 9, throttle has to be under 80% for 9 seconds before this resets back down again. And if you're off the throttle for 9 seconds in a race, I think the launch control is the least of your worries. You're going to need the launch control to get going. All right, so here you'll see the table a little bit simpler, and we've shown you that that's the finger throttle there, the full throttle timer there, and the settings that we've suggested. Are these settings, and my friend Dean is going, are these settings shown relative to SHO? Yeah, this is an SHO FZR setting, and this is where you'd start. So if you get this set up, you'll test it, and if it still cavitates badly, you make these numbers smaller. These are quite aggressive numbers, as you can see, but maybe you might back off to 50% earlier. So this one here I'm setting to, make that 50%. Only thing, if you go to study this, is going to be hard to remember now, but you can't, your full throttle timer setting needs to be below the lowest number here. So if you've got a number of 50 here, this needs to be 45. I won't go into the details of what's happening, but what happens is it gets stuck halfway. So your full throttle timer trigger needs to be lower than the lowest setting you've got in your table. All right, that's it. I've bored you for long enough. We've got some details of our support here. Thank you everyone for coming along. Hopefully we didn't go on too long. I'd actually, just before you go, I'd actually like you to fill out some polls that I meant to ask you right at the beginning. Some questions. So just before you log off, I'd like polls. I'd like to find out where you're from. If you just click in where you're from, and we'll broadcast those results quickly. I've got these polls. In fact, I think I can probably multiple open them. So just click on the one that suits you. Like to know what you ride. Another one.